Hey guys, Mr. Milton here. Today we're going to talk about Pythagorean theorem and its converse. Okay. At the end of this video you should be able to find the side lengths using the Pythagorean theorem, and you should be able to classify triangles using Pythagorean theorem. Okay, recall that Pythagorean's theorem is a squared plus b squared equals c squared. Remember that we can only use it in right triangles to find sides as it is written. Okay, let's try it. A right triangle has side lengths of 4 feet and 8 feet. Okay, and we want us to find the length of the hypotenuse. Give your answer to simplest radical form and round it to the nearest 10. So we have 4, we have 8. Doesn't matter which side we call it. C. So 4 squared plus 8 squared equals c squared. That'll be 16 plus 64 equals c squared. So c squared equals 80. We can take the square root of this. I'm going to do it here. To find c, c will equal square root of 80. So we want to put this in simplified radical form. That's finding pairs. What's that go? 16 and 5, I think, if I'm doing that right. 16 and 5. 5 is prime, so we know we're done here. 4 and 4. So simplified radical form. I didn't give myself enough space, but 4 radical 5. Round it. I can use my calculator and do radical 80, and that gives me 8.9. Okay, to the nearest 10. Alright, so there we go, using Pythagorean theorem. Pythagorean triple. A Pythagorean triple is a set of whole numbers that represent side lengths of a right triangle. To see if a set of numbers is a Pythagorean triple, you just plug it into Pythagorean's theorem and see if it works or not. Okay, so we have 8, 16, 24. You can just plug it in. 8 squared plus 16 squared equals 24 squared. We'll see if that works, and you can always tell how this is going to be set up because the hypotenuse has to be the biggest of the sides. And so 64 plus 1. Nope, it can't be 196. 19 times 19, 361. Nope, that's 16 squared. Sorry, 16 times 16. I think it's 256. There we go, 256. 256 equals 24 squared, which is 576. All right, so 64 plus 256 gives us 320. 576. That does not equal. It is not. Okay. Okay. Determine if this is a Pythagorean triple. 6 radical 3. So in this case, I don't really know what 6 radical 3 is. I think that 6 radical 3 has to be less than 12, though, and it is. So I'd say 6 squared plus 6 radical 3 squared. Equals 12 squared. So 36 plus 36 times 3 should be 108 equals 144. Does that work out? 144 equals 144. So that works. I'll say yes. Okay. If a set of numbers does not form a Pythagorean triple, we can classify the triangle by its inequality. Okay. If c squared is greater than a squared plus b squared, then we know that the triangle is obtuse. If c squared is less than a squared plus b squared, then we know that it is acute. Okay, so you can think of it as if the hypotenuse is really big, it's an obtuse triangle. If the hypotenuse is too small, it's acute. Okay, so we're going to classify this triangle by its angles. Okay, which side lengths? So we have a triangle 4, 6, 7. We're going to see whether it's acute, obtuse, or right. It can still be right. Okay, again, the tip for this is to make sure that you have what would be the hypotenuse by itself. The largest number has to be the number by itself. So you have 16 plus 52, plus 36, thinking ahead, equals 49. So we'll have 52 and 49. Okay, I just kind of put this equals here as a placeholder because I don't know what this inequality is going to be. But now I see that AB is greater than C. So since A squared and B squared is greater than C squared, I know that this is going to be an acute triangle. Okay, if the legs are bigger, it's acute. If the hypotenuse is bigger, it's a hypotenuse. Okay, do the same thing here. We have 8 squared. They try to trick us a little bit by putting it out of order, but we're going to make sure that we pay attention. We're going to make sure that we pay attention to the fact that the largest side has to be by itself. So 64 plus 225 equals, what was that? Something 9. 17 times 17 will give us 289. So that will give us 289 equals 289. That equals, and so therefore it is a right triangle. Okay, so it still can be a right triangle because if Pythagorean theorem works out, it is right. Alright, so identifying the triangle as obtuse, acute, or right using Pythagorean theorem. Alright, application here. A baseball diamond is actually a square with 90-foot sides. How far to the nearest foot does the catcher have to throw the baseball if he's throwing from home plate to second base? So here we go. I'm going to draw a baseball diamond. Okay, catcher would be here. Second base would be here. I'll just call this second. I'll call this C. Okay, and we're trying to find this distance. So what it tells us is that this is 90 feet sides. And since this is a square, I know this is 90 degrees. Okay, and basically what they're asking us for is this distance. And we can find this distance because this is going to be a right triangle. We can find this distance of the hypotenuse by saying 90 squared plus 90 squared equals our hypotenuse squared. I'm just going to call it h squared. So 90 squared is 8,100 plus 8,100 equals h squared, so 16,200 equals h squared. In order to find h, I'm going to take the square root of 16,200. Hope that comes out to be a really nice number, and it didn't. Okay, but that's okay. So h will be 127.3 feet. So from the home plate to second base is 127.3 feet. Alright. Okay, number 2 says find the area of the triangle below. Remember, to find the area of a triangle, we know we're going to need its base, its height, 1/2 base times height. Okay, so what we already have its base. We don't have its height. That's kind of the thing that we have to find for this problem. We'll use Pythagorean's theorem. We see that this is an isosceles triangle here because they're both 29. Makes these bases the same. And what that will help us to figure out here is actually that since these two triangles are the same, that means that these two sides are the same as well. So while they gave us that the entire base was 40, it's going to be important for us to see that this side of the triangle is 20, and each side is 20. And so now we can use that along with Pythagorean's theorem to find out what h is going to be. Okay, because now I know that h squared plus 20 squared should equal 29 squared. H squared plus 400 should equal whatever 29 squared is, 841. I'll subtract 400 from both sides, so h squared equals 441. Take the square root of that, and that will be 21. Nice. Love it when they come out to be nice whole numbers. So now our height is 21, and so now I can plug that back into my equation that we needed at the beginning and say, okay, 1/2 40, which is 20 times 21. Our area would be 420, we'll just say units squared. Okay, 420 units squared. Alright, final problem here. It says find the lengths of the indicated sides if the area of triangle ABC is 24 feet squared. Give your answer in the simplest radical form. Then classify triangle ABC by its angles. So here we go. They gave us the area. We know that area equals 1/2 base times height. Okay, so we know the base. The base is 4 plus 12. Or sorry, 4 plus 8, which is 12. Alright, so now we can use this and say, okay, well, if the area, we also know the area is 24 feet. So if the area is 24, we know this equation. I'm just going to rewrite that because that's messy. 24 equals 1/2 base, which is 12, times height. Well, we can find the height because it's the only thing we don't know. 24 equals 6h. I'll try to get h by itself by dividing by 6. And so h will equal 4. This is our height. Okay. So now it asks us to find AB, which we can find in simplest radical form by using Pythagorean's theorem, which will say 4 squared plus 4 squared equals, let's call this x squared. So 16 plus 16 equals x squared equals 32. Take the square root of that. X will equal 16 times 2, or 4 radical 2. So AB is 4 radical 2. Okay, and now they ask us to find BC. Again, we can do the same thing because it's just a right triangle on the other side. So 4 squared plus 8 squared will equal y squared. 16 plus 64 equals y squared. Y squared will equal 80. So y will equal the square root of 80, which I think we've seen already today, which is 4 radical 5. Finally, they ask us to classify triangle ABC, and they're asking us to classify by its angles. Well, ABC is going to be, okay, ABC is this big triangle here, right? And so we have the sides 4 radical 2, we have the sides 4 radical 5, and then we have this side 12. And so we'll use that in Pythagorean's theorem. 4 radical 2 squared plus 4 radical 5 squared, and then we have this 12 squared. Okay, I'll just leave this blank right now. It looks like an equal sign because I don't know what that sign is going to be. So as I square this, that'll give me 16 times 2, which is 32. 16 times 5, which is 80. 12 squared is 144. So I add these two together, that gives me 112. 112 is less than 144. So a squared plus b squared is less than c squared. That lets me know that this is an obtuse triangle. Alright, so a little bit of everything on that last problem. Hopefully you are got used to using the Pythagorean theorem and its converse to find the sides and to identify and classify triangles. Alright, see ya.